Hello everyone, and then welcome to another tutorial video. So in this video we'll be treating what or evaluating integral of what polar domains. So initially we did that for what rectangular domains. In case you've watched our previous video on integration by rectangular domains, you will get to understand the whole concept. If you haven't done that, I'll urge you to go watch that and then come back to watch that of what the polar domains, because for the rectangular regions, that's where we go to understand the concept, and then we are now implementing the same concept when it comes to what integrating with respect to what or over what polar domains, right? So in case you are new to this channel and you want to see more of these videos, I would urge you to subscribe to the channel, turn on your post notification so that you don't miss out on future videos. Like the video, share, and in case you have any questions, okay, just leave them in the comment section and then we will reply to them as soon as possible. Right, so let's treat this concept of what evaluating integral over what polar domains. So for integrating what over polar domains, okay, let's say we have what function with what v being equal to what our double integral. So initially we got to know that we have what multiple integrals, okay. That's where polar double integrals, triple integrals comes in, okay. But with respect to this concept, we are dealing with only what double integrals, okay. So for this double integral, we have a function with what r and what theta. So now, and then we have what change in a. So note that the change in a is what the change in area, and then this will give us what the what r, okay. So whenever you multiply this function with what the area, you get what volume, okay. That's what the whole of this concept implies, okay. So change in area multiply this entire what function respect to what r to what the change in area, you end up with what this volume, okay. So now this is how we expand this concept, okay. So for r, for here you'll be given what r1 and what r2 respect to what their angles, okay. So r1 respect to what theta, r2 respect to theta, and then we have what the function f respect to r and theta, and then we have what take note of this what expression, okay. It's very important. Keep that in mind, okay. Keep this entire what expression in mind, because that's what we'll be using throughout this video. So we have what the function f of what r and what theta, and then we have another r over here. That's why I'm saying that keep this what equation in mind, okay. We have another r over here. This r is very important. We'll be just implementing this r throughout the examples we'll be solving, okay. So we have what the r and what the theta. So the r and the theta will give us what the a, and then we will multiply that by this function, and then we get what volume. Now, as I said earlier, you'll be given r1 and r2 respect to a theta, okay. And then for alpha and beta, you'll be given what a quadrant, okay, a quadrant or quadrant. So from this question, you can notice that we have what we are given what the first quadrant. So it could be first, second, third, and all that, okay. So this is the main concept you need to understand in order to solve this kind of problem. So without further matter ado, let's try solve some problems so that you get to understand the concept of what evaluating integral of what polar domains. Now let's take this question for example. So we have to do what? Evaluate this integral, okay, sin theta dA, where r is the what region, okay. R is the region between what r2 and what r4 in the first what quadrant. So in every question when it comes to what polar domains, you'll be given what the quadrants. It could be first, it could be second, it could be what third, it could be fourth, okay. And then you have to know what each of what the respective values for those quadrants, okay. So I'll be giving you only the quadrants for the first one, okay. I'll be giving the values or the regions for what the first quadrant. So for the second, third, fourth, you have to find out yourself, okay. That's just a simple assignment for you to get to find out. So let's look at how we solve this problem, okay. So we have what the first quadrant. For the first quadrant, we start from what point 0, okay. These are point 0, and then we have what from pi on 2, okay. That's for what our first quadrant. So I've given you the first quadrant. Let's go and look for what the second, third, and fourth quadrant, okay. Now for this question, okay, we've been given what the integral, okay, to what this is integral. So we have what sine theta, okay, and then the a. Now we've been given what r1 and r2, okay. So we've been given r1 to be 2, r2 to be 4, and then you are told that is what for the first quadrant. So we have what? From 0 to what? Pi on 2. Okay, note that from here you got to know that I told you that this r is very, very important. So in order to make this expression complete, you introduce your what? Your r. Okay, you introduce your r. So now you could solve this problem. Okay, so from here you could further write this as what? Maybe from 0 to what? Pi on 2, and then we have what? From 2 to 4, and then we have what? Sine theta r. Okay, then we have what? Since you've introduced your r, we have what? The r, and then we have what? The theta. Okay, so from here you'll be integrating respect to r, and then you'll be integrating respect to what? Theta. That's why I told you that you need to bring this r. Okay, so from this general formula, I wouldn't bother myself bringing the r, but since it's important, that's where you'll be integrating respect to. Okay, so first you need to integrate with respect to r. After that, you integrate with respect to theta. So let's see how we do that. So first, let's integrate with respect to r. So we have what? 4 on 2, and then we have what? Sine what? Theta r. Okay, and then we have what? The r. So we are integrating with respect to what? R. So when you integrate with respect to r, you end up at what? You integrate with respect to r. So r is something like integrating something like x. Okay, you end up at what? 1 on 2. Okay, x squared. That's the main concept. Okay, right. So let's do that. So we have what? Integration with respect to r, we end up at what? 1 over 2. Okay, r squared, and then you maintain your sine theta. Okay, sine theta. Right, so after that you insert your what? Your limits. So let's solve that. So let's first insert 4, and after that you insert 2. Okay, so we have what? 1 on 2, r is what? 4 squared. Okay, and then we have sine of what? Theta. Okay, minus what? 1 on 2, r is what? 2 squared, and then we have what? Sine of what? Theta. Okay, so from here, when you simplify this, you end up with what? This will give us what? 8. Okay, 8 sine of theta minus what? This will give us what? 2 sine of what? Theta. So now we are not done. All you have to do is just integrate with respect to what? Theta. So we are done with what? Integrating with respect to what? The r. So now we have to integrate with respect to what? The theta. Okay, so this is what? The same as what? Let's find the quadrant. That's the first quadrant. So we have 0 to pi on 2. Okay, so from 0 to pi on what? 2, we have what? 8 sine what? Theta minus what? 2 sine of what? Theta, and then that's what? The r. Sorry, the t. With respect to what? The theta. Okay, so you could just put this in brackets. Okay, so you could just put this in brackets. So when you get to this point, all you have to do is just integrate. Okay, integrate this expression. So in order to make this video short, you can take the time to pause this video and then try integrate, and then find out whether you end up with the same answer I will get. Okay, I want to make this video as short as possible because the second example is very, very long. Okay, so with respect to this, you know how to integrate with respect to trigonometric functions. Okay, so when you integrate this, you are supposed to get your final answer as what? 6. Okay, so try solve this question and then find out whether you get what? 6. Okay, as the final answer. In case you did, just let me know in the comment section. In case you did not, also let me know in the comment section. Okay, so let's proceed to what? The second problem. So this is what? This just the first problem. Let's look at the what? The second question. So this is the what? The second question. Okay, so we have to evaluate what? This integral. Okay, where r is the region bounded below by what? 2, and then bounded above by this expression. Okay, 2 multiplying what? 1 plus cos theta, and then this also for what? The first quadrant. Okay, so let's see how we solve this problem. So we have what? The solution. So we know that this is what? Double integral. Okay, so we have sine of theta a. Okay, and then we know what? R1 and R2. R1 is what? 2. R2 is what? 2 multiplying what? 1 plus what? Cos theta. Okay, and then we know first quadrant is from what? 0 to what? Pi on what? 2. So let's try expand this. Okay, this is what our first quadrant, 0 and then pi 1 what 2. So you could just rewrite this as what, to make it clearer. So 0 to what, pi 1 2, and then we have what, 2 to what, 2 open bracket 1 plus what, cos theta, and then we have what, sine theta r dr d theta. Okay, now let's try solve this problem. So from here, this as our previous problem, we got to know that we have to first take the integral, okay, for r. So we have what, 2, and then we have what, 1 cos theta, okay, and then we have what, sine of what, theta r dr. So you could just do the simple what, integration, okay. So we have what, 1 on 2, when you integrate respect to r, 1 on 2 r squared sine theta, okay, and then we have from what, 2 to what, 2 multiplying what, 1 plus what, cos theta, okay. Now you could just further what, simplify this. So when you simplify this, you get what, 1 over 2, and then we know our r is what, so we are taking the upper limit first. So we have what, 2 plus what, so we have 1 plus what, cos theta, okay, all squared, and then we have what, sine what, theta, okay, right, and then minus what, 1 over 2, okay, and then we have what, 2, okay. So let me close this over here, and then the squared will be here, okay, and then we have what, 2, okay, squared sine theta. Note that you can further expand this, okay, can further expand this and make it simpler. So we have 1 over 2, so this will give us what, 2 plus what, 2 cos theta. I'm just expanding this, okay, square, okay, sine what, theta minus what, 1 over 2 exponent 2, okay, sine of what, theta. So when you expand this, what's in the bracket, okay, we are concentrating on what's in the bracket. When you expand this, we have what, 2 exponent 2, that's what, 4. So this is what I mean. So this is what, something like a plus b, okay, something like a plus bx squared, okay. So we have what, a squared plus what, a times bx. So we have what, a bx all multiplying by 2, okay. I want to show you the expansion so that you don't get confused. So let's say we have what, x plus what, y, okay, all squared. So this is what, x squared. When expanding this, and then we have what, 2 times xy, okay, and then plus what, y squared, okay. This is what I'm using. This is the expansion I'm using. So don't get confused when I do the expansion. So you can just refer from here, okay. This is the expansion I'm using. I want to make this video as short as possible, so I won't go through certain kind of what, you know, expansion, okay. So let's proceed from there. So we have what, this will give us what, 8, okay, cos theta, then we have what, 4 cos squared theta, okay, and then you close the bracket, we have what, sine theta. That's from here. And then when you use this as expansion, okay, you get to know that you end up with this what, expression. So we have what, 1, okay. So let's do same for here. So from here you have what, 1 over 2 exponents what, 1 over 2 times 4, so that's what, 2 sine what, theta, okay. So from here you could just further simplify this, okay, further simplify this and get what, so multiplying 1 over 2 throughout, you end up with what, 2 plus what, 4 cos theta, okay. This will give us 2, this will give us 4, this will give us what, yes, against us right, that's 2. So we have what, plus what, 2 cos squared theta, okay, all multiplying by what, sine what, theta, okay. Then you subtract that from this expression, 2 sine what, theta. So from here you could just further simplify this, okay. Let's multiply the sine theta by what is in the bracket. So we have what, 2 sine what, theta plus what, cos theta sine theta, okay, and then plus what? 2 cos squared theta sine what? Okay, let me write a sine. So we have what? Sine theta, okay, and then we have what? Minus 2 sine of theta. So from here you could just do your simple what? Cancellation and all that. So we have what? 2 sine theta over here. This is also 2 sine theta. So you could notice that this will just cancel this. Then you'll be left with what? 4 cos what? Sine theta plus 2 cos squared theta sine theta. Okay. So let's do that. So you'll be left with what? 4 cos theta sine theta plus what? 2 cos squared theta and what? Sine theta. So this will be our next what? Integral, okay, to evaluate. So we know that the first quadrant was what? From 0 to pi on 2, and then now we have what? 4 cos what? Theta sine theta, okay, plus 2 cos squared theta, okay, sine what? Theta, okay, and then this will be integrated with respect to what? The theta. So from here, okay, from here you could also go through the same principle, okay, to try and what? Integrate. This is very, very simple when you're trying to, integrate, okay. As I said earlier, I want to make this video as short as possible because most of the videos I've recently uploaded were, long, okay. I want to get your, concentration. So this video is very, very simple. I'll make this video very, very simple. So just as I did for the previous or the first example, once you take the second integral, okay, and then evaluate, and then you end up with what? The answer to what? 6, okay. And then in case you had the same answer, let me know in the comment section. In case you didn't, let me know why you didn't get that answer in the comment section. So the same thing applies to this question, okay. Once you integrate this entire expression, you end up with what? 8 on what? 3, okay. This will be your final answer, okay. So you could even use your calculator to find the what answer, okay. In case you want to see that video, I'll also make that video on this channel. So just go to the playlist and find what calculator tricks on what integration. You also find that, and then in case you want to also solve this manually, just do that. You end up with this answer, okay. So in the next video we might treat integration over non-rectangular regions, okay. You might not, we might do that, okay. It depends on what happens in the future. So I will see you in the next video. Have a lovely day. Bye bye.